So this important question has been asked in CSIR NET. Here you have given two series, AN and BN. B2 series, then you need to prove which series is convergent and which are not, or one is convergent, other is not, or both are convergent and neither or nor it is convergent. So these are the few options. So these are the one standard question which has been asked this type of question in many years. So here for solving this question, we need to recall some basic facts. The fact one is the Dirichlet test for convergence of product of two series. So if you think about the series A and Bn is convergent or not, so on that case, if Sn be the nth partial sum of the series An such that Sn is bounded and B is a monotone sequence, that means either monotone increasing or decreasing, it converges to 0, then we conclude A and Bn. Now we come to the problem, the first series, that series is convergent or not. So here we consider An, that series An is basically sine n pi by 2 by root n, that series. So now we consider say un equals to sine n pi by 2 and Vn, this is equals to 1 by root n. So if we consider this, so here you will see if we take the sequence of nth partial sum Sn equals to u1 plus u2 plus un that we define. So on that case, this sequence of partial sum, it must be bounded. So this sequence of partial sum Sn, that is bounded. You can check it easily, as in sine of theta is always less than equals to 1. So this value is less than equals to n for all n belongs to natural number. Now we come to the second series Vn, where if we take the sequence, that sequence Vn, so that means 1 by root n. So this is a monotone decreasing sequence and this sequence converges to 0. So Bn, that sequence is monotone sequence. So by using the Dirichlet test, what we conclude? We conclude un Vn, that series is convergent. That means the series An is convergent. So this series An is convergent. We can easily check with the help of Dirichlet test. Now we come to the second series, that is the series Bn is convergent or not. So in that case, what we'll do? So we'll check here the log 1 by 1 plus n square. Okay, so this series is convergent or not, that we need to check now. Okay, now we calculate here. Say we calculate, we will apply the comparison test of limit form. Say we take here another series dn, this is equals to 1 by n square, and we calculate limit n tending to infinity bn by dn. So that means limit n tending to infinity log of 1 plus 1 by n square by 1 plus n square. You will check this limit will be log e and it will be 1. So this is a finite non-zero real number. So here we can say n and dn are converge or diverge together. Converge or diverge together with the help of comparison test of limit form. So this is comparison test of limit form that we can say here. Here 1 is basically non-zero finite number. So since and we also know this is another recall, the summation 1 by n to the power p, that series is convergent if p greater than 1. So therefore 1 by n square is convergent as p equals to 2 greater than 1. So with the help of comparison test of limit form, we can conclude also the Bn series. With the help of comparison test, Bn series is convergent. Because we have already concluded A and Bn are converge or diverge together, since the series Dn is, already convergent with the help of p test. So in that case, we can say the series Bn is also convergent. So both the series An and Bn are convergent. So option C is correct. All other options are false.